Greetings everyone, my name is Bhave and I'm going to be talking about my capstone project with DQ Systems. First off, I would like to thank Dr. Gates and DQ Systems for making this collaboration possible. Let's talk about DQ Systems as a company and what they do. DQ Systems is a leading company dedicated to digital accessibility solutions. They offer tools and services that help organizations comply with their accessibility standards, improve digital experiences, and integrate accessibility into their development process. One of their key offerings is Axe, a suite of accessibility testing tools that help detect and resolve accessibility issues efficiently. More specifically, let's talk about one of their products, which is Axe Assistant, which my team and I are working on. My team consists of myself, Siddharth Mathur, Abhijay Tyagi, and Rahul Shetty. So, what does Axe Assistant do? Axe Assistant, developed by DQ Systems, is an AI-driven tool designed to provide quick and accurate answers to accessibility-related queries. So it's basically a chatbot. It is trained on DQ University's vast knowledge base, enabling it to categorize and address user queries efficiently, offer real-time guidance on accessibility compliance, and generate accessible code snippets and provide documentation references. So our project is to improve Axe Assistant's current implementation and to improve its efficiency, maintainability, and response accuracy. While the existing system is effective, there are several areas where improvements could be made, including reducing complexity, improving query handling, and optimizing resource allocation. So at the moment, Assistant follows a bot-based architecture which has three bots: a chatbot, a concise bot, and a tools bot. There are certain challenges that this architecture faces, and to overcome these challenges, the current DQ team is working on adopting an agentic workflow that is shown over here that aligns with the industry's best practices, such as an orchestrator worker pattern. And this approach involves specialized AI agents working under the central manager agent, as you can see in this architecture diagram. And this is where our students come in to assist with this. So the key agents in the new model include DQU agent, the products agent, the developer agent, and the remediation agent. I believe the remediation agent has now been changed to an FAQ agent. So what happens here is the input of the user prompt is the input. It goes through the manager agent, and the manager agent analyzes the user prompt and accordingly picks the best specialized agent it can for the most optimized answer as well as the optimized resource allocation. So there are certain benefits to this agentic architecture, and it offers better task specialization. It orders a reduced complexity, improved response time, as well as easier maintenance and scalability. So we were tasked with engineering the manager prompt, which would be passed to the GPT API along with the user prompt, and the API would respond by an analysis of the intent and classifying the type of response that is required, as well as the desired output to the user prompt. Let's talk about the results of the latest task. This is what we had done initially. So as you can see here, before this was the prompt manager prompt that they had, and on the right you can see is the improved prompt that we engineered. So some of the results, as you can see here, are the query classification accuracy. You can see that 85%, 85.7% were correct classifications and 14% were misclassifications. This is a significant improvement from the previous part of the project where we, as in now we have almost doubled the accuracy. And here are the more specific accuracies of the type matching as well as the output matching. You can see there's an 82.5% as well as an 87.3%, which are very good results. And the team at DQ were also satisfied with these results. The classification accuracy over the number of test cases, as you can see here, is as the number of test cases go up, the accuracy does go down a little bit, but we are still in the range of high 80s by the end of the last test case, which is good. And the manager prompt also decides which agent is to be used. So these are the agents that are being used for the prompts that we have. And this is an accurate result for us. And we are happy with this result. And after this task, my teammate Abhijay and I, we were assigned to another task of building a comprehensive dashboard to analyze the data of the chatbot, including user prompts and the topics that they were asking, the response times of the chatbot, an analysis of the clients that were using the chatbot, a sentiment analysis of the user prompts, as well as the responses from the chatbot, and a few other specific requirements. And so we were provided with SQL data that we had to set up locally on MySQL Workbench. We also had to write certain SQL scripts to deduplicate the data that you can see here and remove redundancies. So we carried out this deduplications using these queries that you can see here. And to build the dashboard, our approach was to use Streamlit. And initially, we used a direct database connection via Python to connect to the database. And we used Streamlit along with visualization libraries like Matplotlib and Plotly. So this is what the dashboard looks like. This is a screenshot of the first page. And as you can see on the top, there are certain KPIs, which are total interactions, a positive interaction, positive reaction rate, the number of feedback responses, and the average response time. So let's look at some more key metrics that we found out. See, so there are 1,478 unique users and a total of 36,000 total interactions across all users and clients. So let's analyze the response time over here. As you can see, if the uh, reaction by the user was a thumbs up, the average response time in that case was 9.21 seconds and a standard and a 7.97 of sigma. And the thumbs up responses had a average response time of 11.74 seconds. So this indicates that there is not necessarily a correlation between the user being satisfied and the response time being low. So it means that faster response times didn't necessarily yield higher satisfaction. So we found no correlation there. So this was an actionable insight for us to prioritize quality over speed in responses. So this is the sentiment and satisfaction. Most of the responses had a neutral sentiment, which is almost 94% of the responses had a neutral sentiment. And there was a few negative as well as a few positive. And so raw sentiment, what we found here is raw sentiment has virtually no predictive power for user satisfaction. The thumbs up responses had slightly more positive sentiment than thumbs down, which doesn't necessarily indicate much as the difference is very minimal. And these are some of the client insights. We analyzed the number of interactions and other variables as well for each client. So these were scholarship subscriptions was the number one client with the most number of interactions. These were subscriptions provided to certain students of DQ University with they were provided the subscription and they had the most number of interactions. The second was DQ and the sales demo accounting, which are both the internal teams at DQ University at DQ Systems. And le- shortly after is the Government of Canada. Both of these are Government of Canada as their next top clients. And this is where we found some more interesting things. Here is the topic distribution of the user prompts. So this is where we analyze what kind of topics the users had most questions about. So 10.48% of all the interactions, which was 36,000 interactions, were 3 points were screen about screen readers. The second was about ARIA, which is an accessibility related topic. The third was alt text, and the fourth was also ARIA labels more specifically. So what this let us know is that there might be a knowledge gap in these top topics. So we could suggest to DQ that they potentially hold workshops or seminars about these topics, or even maybe upload more content about them. And so this indicates some good insights to us. And let's have a look at the dashboard itself over here. Here we interact certain trends over the week, and this is a graph for the interaction volume by hour of the day. So you can see the most number of interactions came around the afternoon between 2 p.m. and 4 p.m. There was also a lot of interactions at 3 a.m. in the morning, which is a little surprising. And interaction volume by day of the week, as you can see, Saturday and Sunday was the lowest. So this is obviously the weekend. And Friday had the highest number of interactions. And let's look at some more of the analysis that we had. And this is the prompt sentiment distribution. As you can see, the graph is the distribution is mostly neutral. It's all around zero. And we were also asked for another requirement where Paul preferred that he would like to see, let's say there are certain prompts with negative sentiments. He would like to actually see those prompts and why they have a negative sentiment. So we also implemented that requirement for him. And so as you can see, here are a list of filters where we can filter by client, client type, client sector, and client country, and many more things. Here is a topic analysis. So these were the topics that the users were asking. This is the distribution of what it looks like. Let's also look at the response analysis. Here is where we analyze the response times as mentioned earlier. So you can see the mean time and the median time for thumbs up and thumbs down reactions and the count for it as well. and the success rate also by response time range. So there was not much to see here. And this is the graph of the client analysis. Moving back to the presentation. So the next steps and conclusion for this project is that this work has helped us move from assumptions to real actionable understanding. We've analyzed over 36,000 interactions and uncovered critical patterns in user behavior and identified where our chatbot performs well and where we have clear opportunities to improve. We now have a roadmap built directly from user insights, one that focuses on enriching the experience, responding more thoughtfully, detecting and managing frustration earlier, and strengthening our educational support through DQ University and live engagement. Most importantly, this project reinforces that we're not just building an AI assistant, but we are creating a smarter, more human-centered support experience that reflects DQ's leadership in digital accessibility. I would also like to sincerely thank the DQ team for their trust, collaboration, and commitment to innovation. Together, we are making meaningful steps. And the next step for us is that we are going to be presenting our findings to executive members at the DQ team. And we're also going to provide suggestions based on the analysis and ways that the AI chatbot could improve, as well as certain things at DQ as a company. Thank you.